Greetings, this is a video to show you the final practice exam for BDAN 310. Let's get started. So I'm at Blackboard. There's the link for the final practice exam. When you start it, it's going to say, are you ready? Are you sure you want to do this? Yes, I do. Continue. And once you're into the practice final exam, as you scroll down here, there are some things you'll recognize from the midterm. For example, at the very end, this time we have the honesty statement, the honor statement, basically that you're acknowledging that you agree to the student code of conduct, etc. That'll be your very last question. In the last one, I believe that was the very first question. And you'll see it with question 1, you're prompted to download a file, a start file. I'm going to do that. Right click it, save link as, and when you do that, you're going to get the file that you see right here. And I'm going to open that up. When that opens up, I should see a yellow bar across the top saying enable editing. You click on that. You'll again see the WKU code of conduct up there, basically acknowledging the things that you can and you can't do in the real final exam. And then we're ready to get started. So we click to, you'll see there are a lot of different worksheets in this workbook. We're going to work from the first one here. The marketing domestic beer worksheet is our first worksheet to work from. As we go back to the questions, we'll see in question 1, it's going to ask us to do the following. As you can see, we're to make a scatter plot, and then from the scatter plot, we're supposed to have it then create the trend line, which is going to also allow us to see the equation used to create that trend line, as well as the R-squared value that goes with that. So let's jump over to Excel and do that, and we'll zoom in just a little bit. And the things I need are the expenditures and the shipments here. So these are the two columns which I need to use for this. So I'm going to select these items, and I will then insert a scatter plot. You can click down here and go through that route, or you can just use this little drop down box right there. What I want is a XY scatter plot, and this is the one I want right here. And once I have those points, I then need to, by clicking on any of the dots in here and right clicking, I can add a trend line. And I also want to see the equation that is used to make that line, as well as see the R-squared value. Make that where I can see them right there, and get rid of this box right there. I don't need it anymore. And so that tells me I have a regression line between these points. That is the slope. There's the y-intercept on it. The R-squared value is 0.78, so I have a strong correlation between these two items right here. And with that equation right there, I can then go back to my question, and I can then make a prediction. If I had a number of shipments expected when the media expenditures were 40 million, I can come back to here and, based on this input of 40 million for X, I can come here, and then I've got this value right here. So what I'm going to do, just to make sure I can keep track of what I'm doing, I'm going to Q1 and Q2 here. These are my the value that I'm going to use for this equation right here is I'm going to just tell Excel to do some work, give it the equal sign, and I wanted to take 0.1955 and multiply that times, I believe the value was 40 million times 40. And then I want to, as you can see, add this y-intercept of 4.089, and that's going to give me a value of 11.9 for the shipments. So if I had a expenditure of 40 million, then I would get a shipment of 11.9 million. Probably need to round that to, let's see what it wants for rounding. Round your answer to 1 decimal place. So I'll take this and just select that value and decrease it down to 1 decimal place, 11.9. The next question is what is the R² value for that regression line, and that is supposed to be rounded to 2 decimal places. So I look back at my chart, it tells me that my regression, my R² value is 0.783, so that's going to be 0.78 if I round that to 2 decimal places, right? So 11.9, 0.78 for questions 1 and 2. So let's save our work and we'll move on to the next question. All right, our next question, questions 3 and 4, come from this worksheet, and I'm not going to zoom in there too closely. You can see that these are companies and then fair value and share prices for those stocks, I believe. As we look at these different listed items, there are 28 total, and what they want us to do in the question is they want us to basically make a scatter plot, get the trend line out there, that's the regression line, and use that equation that comes with the regression line to see what a $50 fair value would give us as far as share price. And so that's our next step, and then we're supposed to look at that trend line and decide about its correlation, whether it's positive or negative, or if we don't have enough information. So again, we're looking at the share price and the fair value. So let's go over to the sheet here. We've got these two guys right here. And can you include the top row? If you'd like to, you can. That's fine. I'm going to go to Insert and put a scatter plot in here. An XY scatter looks like this. Okay. And to get the trend line, just select any of the circles, any of the dots on there, add the trend line. Again, we want to see the equation as well as R² value. That will come into play later. So there we go. We've got that on our screen, and we're supposed to then look at if we had an additional company out here with a fair value of 50, what would its share price be? We use this equation up here to calculate that. And let's go ahead and get Q3 and Q4 onto the screen so we can put our answers here. I'm going to enter that formula. So I put the equal sign telling Excel to do work, and it's 0.9113 times the X value of, I believe it was 50, right? $50 times 50. And now this time, note that the y-intercept is negative. So I don't put a plus here. I use a negative. So I'm going to subtract 2.9874, and that will give me, and this one I believe probably wants 1 decimal place. So I will take that value and reduce it down to 1 decimal place. So my share price would be 42.6 for something with a fair value of 50. And as I look at my R² value, I've got a 0.76, so I have a strong correlation between those. It's a pretty good prediction. Now the question asked for question 4, though, is whether this trend line that that Excel made for us, whether that represents a positive or a negative correlation. And as you look at the chart right there, you can see that it's going up and to the right, and that tells you that it is a, and then the choir said it's a positive correlation. That it's a positive correlation. If it was negative, it'd be going down and to the right, as opposed to up, right? So, and we definitely have enough information to make that judgment right there. So the answer on this one is going to be that is a positive correlation, and the value was again 42.6 for the share price if we had a $50 fair value. So that's question 3 and 4. All right, our next question, number 5, wants us to go to the next worksheet, which is over here. And by the way, save it. Save early, save often. Jump over here to question 5, NFL revenue. And you can see that there are different franchises, different teams listed here, as well as their revenue and then the value of the teams coming in. And as we look at the question, it says, what would the predicted team value be of a team that brings in 250 million of annual revenue? So what's the total value of the team if it gets 250 million in revenue? It's the same thing again. We're trying to give you lots of practice doing these things. So come the real test, the final, you'll have lots of practice with this. So let's jump here. This time I'm going to include the top row. Again, these are the revenue versus the value. These are the things I want to chart. I'm going to insert the scatter plot. Come down here to the scatter plot. That's the one I want, but if I didn't see that, I could come down here to XY scatter. It's this one right here. Okay, those are really closely clumped together. Again, same process. Let me get this guy up here just a little bit, and I'll zoom in just a touch so you can see that better. And just right click one of the points, add the trend line, as well as the R squared value. And there you go. And I believe this is question 5, so we're going to put Q5 here. And what they want us to do is, if a team had revenue of $250 million, what's its value going to be? We can use this equation right there to calculate that. So to make that happen, we insert our formula. Equal sign tells Excel to do work. And we've got a formula of 5.8317 times 250 million, or 250. And this time, again, note that the y-intercept here is negative. So instead of putting plus, we're going to put minus 252.08. And that should give us a value of, as you see right there, 1,205. And this one is also, I believe, rounded to 1 decimal place. So we'll take that value and round that to 1 decimal place. So 1,205.8. And in question 6, I believe, also has to do with the 3 things we've just finished. Let me save what I have right now. So as I look at question 6 over here in Blackboard, it says, which of the 3 things you've looked at so far, the marketing domestic beer, Morningstar fair value, and NFL revenue, which one do you have the highest confidence in your prediction? Which one has the best R squared value? And so as you go back and look at your charts here, that tells you that the R squared value is 0.7673 on this one. Coming back, and that's for the NFL. Coming back to Morningstar fair value, you've got a R squared value of 0.7694. And coming over here to the marketing domestic beer, it has a R squared value of 0.7834. And again, the higher that is, the more sure it is. If you had a R squared value of 1, you can make a perfect prediction, right? And so again, we're looking for the highest R squared value between those 3. Make your selection, and then you will put that in Blackboard here. Let me get my things entered, and we'll move on to question 7. All right, so the next 4 questions are going to come from this worksheet right here. It's called Forecast Yearly Sales, question 7 through 11. Let me zoom in here so that we can see this a little better. And with this, we're going to start our forecasting work. So far, we've been doing regression analysis with the preceding 3 worksheets. This one's going to be our time series and forecasting stuff. And you'll see that there are years here, 1 through 10. There were sales in those years of those amounts. And what they want us to do, so down here in year 10, we don't know what has happened in year 10 yet. It hasn't happened yet. We've gone through years 1 through 9. We're guessing about year 10. And so as we look at the question, let's look at questions 7 and 8 together here. They want us to use a 3-year moving average to determine the forecasted demand for the years 4 through 9. And then do the mean absolute deviation, calculate the mean absolute deviation value of that 3-year moving average, and tell it what it's looking for is the mean absolute deviation value right there of those of those forecasts. And so let's jump over there and then and get that. And also, what you'll see with question 8, it also wants to know what is the year 10 forecast using that 3-year moving average, which you did up there. So what you can do is kind of combine these two together as you work towards the answers for 7 and 8. So let's jump over here, and what you'll see is we're going to do the 3-year moving average. All right. Again, a 3-year moving average is what we're going to do here. And we have to start in year 4 because you need 3 years of data in order to make the prediction for the 4th year. That's what the 3-year moving average is telling you, is that you looked at 3 years. Based on those 3 years, what's the 4th year? And so it's simple. We're just going to use the average function. So we give the equal sign and tell it to use average. So equal sign, hey Excel, do some work. Use the average function, and then jump in for the parameters in here. We're going to say use those first 3 years because we're in year 4. And we close the parentheses, and there is our guess for year 4. And what we'll do is we'll just fill this down the column, including year 10, and that tells us what our what our guesses are going to be. And I think what they wanted in this one is rounded to 1 decimal place, so we'll round those values to 1 decimal just to save ourselves some time a little bit later. So that's the first step in this question number 7, and that's our answer to question 8. What's the year 10 value going to be? It's going to be what you see right there, 180.3. So now what we need to do, we need to figure out what the mean absolute deviation is for this prediction. And so I'm going to put my absolute values for these for 3 year. So what I'm going to do in this column right here is I'm going to calculate what the difference is between what actually happened and what I predicted. I want to figure out what is the difference between this and that. It could be positive, it could be negative. This is the second step in getting to the mean absolute deviation. You remember this from when we did the forecasting homework back in, I believe, unit 6. And so when you do this, and all we're going to do it for is the years 4 through 9. And we can't do it for year 10 because year 10 hasn't happened yet. We don't know. We don't have a real absolute. We don't have an actual value to subtract that from. So all we can do it for is the years you see right there. So just to remind you, you put the equal sign in there and you tell I want to use the absolute. Give me the absolute value of something. That's the function I want. And you just take what actually happened, subtract the prediction. That was our 3-year moving average prediction, right? There you go. And it's actually a negative 50, but because we're using the absolute value, it's going to give us just that number, whether it's positive or negative. And then we can just fill this down through years, these years as well. That's the second step. We found the absolute values for those differences. Now the last step, the MAD value. I'm just going to give the MAD value here, and I'll just put the greater than symbol there to point to it, and just make that a little bit. Bear with me 1 second. Okay, so lastly, what I'm going to do, just to calculate that MAD value, I'm just going to average those differences, the absolute values right there. I'm just going to average those. So I just go to average. There it is. And I select those guys right there. And I'll believe that he wants that to be 1 decimal place. You had a 1 decimal place. And reduce that down to 1 decimal place. And that is the mean absolute deviation value for the 3-year moving average, 21.2. So that is our answer. 21.2 is the answer for question 7, 21.2. And this question 8, what is that 10-year, year 10 forecast using that 3-year moving average? As we've already stated, that's going to be 180.3. And so we'll enter that one in there, 180.3. All right, so let's jump down here to questions 9 and 10. We're working from that same worksheet, and this time right next to the things we've already done. So let's color code these just to make them where we know what they are. That helps me keep things straight. And we can even put some borders around this just to help us remember what we're looking at. Do you have to do that? No, you do not. But that helps me work and stay organized. So for my next 2 questions, they want us to use a 3-year weighted average, similar but different. And the weights are 0.1, 0.3, and 0.6. And recall from when we did this forecasting work that the heaviest weight is going to be on the most recent year. So 0.6 will be the closest year to us, and then 0.3 the second closest, and so on. So all of those weights, by the way, have to add up to be 1. So again, for years 4 through 9, let's do a 3-year weighted average prediction forecast for, and using those weights for what we think is going to happen. And then in this one, they want to know what the year 10 value is. So just like we did with the last one, we're going to create this formula that we need for this, and we can just fill it down all the way to year 10. This will be our answer for year 10 right there, and then we'll again calculate that MAD value, that mean absolute deviation value for that item right there. So let's jump over here. We can work a little bit quicker this time. This is the 3-year weighted moving average, right? And this one will be the absolute for weighted. Again, just put labels in here so you can keep straight what you're doing. We have to go down to year 4, and the way this works, remember the weights are 0.1, 0.3, and 0.6. I'll add that in the title up here. Okay, added that in up here, and I'll also color code this just to, again, keep this a little bit easier to read. We'll make this one blue. So, all right, so we go to year 4, and we're going to use the 3-year weighted average. So we put the equal sign to start using a formula. Hey, Excel, do some work. And I tell it, hey, go over to the closest year, that would be year 3, multiply that times my heaviest weight, which is going to be 0.6. Then you're going to add the next year multiplied by the next weight, which is going to be 0.3. Then you're going to add the furthest year times the furthest weight. And you could, and this is a 3-year weighted average we're doing in this one, but you can do 4 years, 5 years, 6 years, 10 years, whatever you want to do. You just change the formula to accommodate the number of years you wish to wait, and then make sure that all these weights add up to 1, right? So with that done, I can then just copy this, fill this down the column here. And like I said, this is going to be the answer to the question number 11, the 181.4. That's our prediction using a 3-year weighted average with those weights for year 10. So that's going to be our answer to number 11. For question number 10, we still need to calculate the absolute difference between what really happened and what we guessed, and then get the average of those differences. So let's do that now. Let's get again the absolute value of what really happened from what we predicted. And again, it's whether that's positive or negative, that difference, it's going to give us just the value, the absolute value. And we only need that for years 4 through 9. And then we calculate the average of those values. And the average right here of these values right there. So that is the MAD value of this 3-year weighted average right there. Let's jump over to our question. Let's save it real quickly. Let's jump over to our question and make sure we're answering what it's asking. So Okay, so the MAD value of the 3-year weighted average is this 18.7. We'll input that, 18.7. The year 10 forecasted value using the 3-year weighted average with those weights was 181.4. 181.4. This next question, question 11, is based on the MAD values, which model would you expect to make a better prediction about year 10, the 3-year moving or the 3-year weighted? As we look at our two different MAD scores right there, again, what we're looking for, the smaller the MAD value, the smaller the mean absolute difference, the better. So between this one for the 3-year moving average or this one over here for the 3-year weighted moving average, which of those is smaller? Select the correct answer there and input it in the question 11 right there. Okay, so let's jump over to our next set of questions. We're going to use this. Questions 12 through 15 come from this forecast Kentucky gasoline right over here. And you'll see that there are years from 1997 through 2009. And then these are retail sales of gasoline in thousands of gallons. And so we're going to be trying to forecast this a number of different ways. And so I'm just going to put my question marks down here. That helps me remember that this 2009 hasn't happened yet. Do you have to do that? You do not. But again, that helps me stay on track. I'm going to zoom in here just a little bit to make these numbers perhaps a little bigger. The first way, we're going to do this 4 different ways. We're going to do forecasting 4 different ways here. The first way we're going to do it is through another 3-year moving average. Then we're going to do a 6-year weighted average. Then we're going to do exponential smoothing with an alpha value of 0.3. And then lastly, we're going to use trend. So let's start with the 3-year moving average. And we come over here and look at the question, forecast, what is the 2009 predicted value using 3-year moving average, round to 1 decimal place. So let's get that one done. So this is going to be 3-year moving average. And I encourage you to label so that you can remember what's going on. And you can adjust the size of the cells so that they look good for you. I paused it and formatted that so that it wrapped in that box to just keep it a little bit skinnier for us. So the 3-year moving average, you know how to do that. We just did it a second ago. We just go to year 4. In this case, that's going to be year 2000. And we want to use the average function. What we're going to average is the preceding 3 years. There's no weight in this one. It's just a 3-year moving average. And with that done, I can copy that down to year 2009. And they want that with a single decimal place. So we've got that done. The next one that they want us to calculate, so you'll see 1005.2 is the 2009 prediction. So as I come over here, what is the 2009 predicted using 3-year? It's going to be 1005.2. And my next one, they want us to do a 6-year weighted moving average using weights of 0.1, 0.1, 0.1, 0.2, 0.2, 0.3. So it's the same thing we did a second ago with the 3-year weighted moving average. It's just over a longer period of time. And if you add all those up, the 0.1, 0.1, 0.1, and so on, all the way, that averages up to, that comes up to 1. If you add all those together. And of course, the heaviest weight goes to the most recent year. So let me get my labels in place over here. I'll pause that while I get that done, and then I'll show you the calculation. Okay, so I've typed that in, and I will create my formula, give it the equal sign, Excel, do some work. Excuse me, I have to start down here in year 7. So this is year 1, 2, 3, 4, 5, 6. So this is my 7th year. This is the first one I can do it in again. It's year 1, 2, 3, 4, 5, 6. And there's year 7 right there. So I tell it, give the equal sign, hey Excel, take the closest year, multiply it times the heaviest weight, in this case 0.3, and then add in the next year times the next weight, and so on. So we'll get this put in place here. And that should give us our estimate for those years. And we'll just drag this down to year 10. Again, we want a single decimal place for those. And let's actually color code these as well. That's what I'm going to do anyway. You do what you want. That guy became another color. That's great. Put some borders around these, make them easier to read. And so my 2009 6-year weighted average estimate is 960.0. So 960.0. And the next one, what is the 2009 predicted value using exponential smoothing with an alpha of 0.3 and a starting value in 1997 of 850. Recall with this method, with exponential smoothing, you have to have there's a given starting point. In this case, it's going to be 850 for 1997. So over in our chart here for 1997, we're going to input 850. That was given to us. And where that would come from in real world is there would be a method to your madness. You may use some sort of averaging technique like we've done here for that starting value. Or you may have done like a bunch of different other predictions and you just average those together to come up with your starting point for the smoothing. But we've been given this starting point of 850 for 1997. From here, we start to use this exponential smoothing technique, and the alpha here, of course, is 0.3. And so let me get that. All right, so I put my smoothing with an alpha of 0.3 in here. I gave it all purple, so I'll know that this is all part of the exponential smoothing technique. And remember that the exponential smoothing is kind of a hybrid between naive and a mathematical or arithmetic based one. And so the way this works is you take your starting point, you're going to start with this, and then you're going to use arithmetic to then sort of smooth that. Okay, so let's make it happen. So again, remember the naive is where you just take what happened last year and you just say, oh, that's going to happen again. So that's where smoothing is kind of a hybrid here. So we start with the initial, what happened, what was the guess last time? And then we're going to add to that, we're going to take the difference between what actually happened and what was predicted, and we're going to multiply that times that alpha value. So in parentheses, you take what actually happened, you subtract what you guessed was going to happen, in this case the initial given value, and then you multiply that times the alpha value, in this case 0.3. That could be more or less. And when you guys looked at the Google Trend stuff from a couple of weeks ago, you could adjust the smoothing, if you remember, on that, and you could make it, if you took the smoothing down to 0 as a very jagged line, and if you let it be, if you use the smoothing, it got a lot prettier. It was a much smoother line. So that's the formula that we want right there. And so with that done, we just take this and populate the rest of our column with it. Again, we want a single decimal with that. So using exponential smoothing of an alpha with an alpha of 0.3, we get a 2009 value of 952.2. And again, that was your formula right there, and you just use the fill mechanism to pull that down to column. So let's get that in our form over here. Again, that was 952.2, 952.2. Let's go on to question 15. Okay, so we go back to our gasoline worksheet one more time, and we create a scatter plot, and then from that we find out what that regression formula is, and then we just added one more year to get a 2009 prediction. Let's jump over here. I'm just going to take these values, and I'm going to, I just chose from C5 down through C16. I'm going to insert a scatter plot here. Put all plots, XY scatter, give me a scatter plot right there. Okay. Right click any of the points, add a trend line. Use that R squared with it if you like. Get it where you can see it. That's not a very strong R squared, as you can see. Let me zoom out just a little bit so I can get this where we can see this better. But we're going to put the, we'll call this trend line. And down here for 2009, let's figure out which year this is. This should be year 13. There was year 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This will be your year 13. So that means the value of X is going to be 13. So we take that formula, use our equal sign, tell Excel to do some work, and we take that formula, you see right there, 16.271 times year 13. That's what year 2009 would be. And then we add, the y-intercept here is 779.71. And we get that to a 1-to-1 decimal place. Gives us a value of 991.2. So that'll be our 2009 value using the trend line progression. Now, note that the R squared there is down to 0.58. That's moderate. That's not very strong. It's got to be above 0.67 in order to be considered a strong, like a prediction you want to kind of put weight on. So this is one that you're going to look at it, but it's not one that you're going to like bet the farm on, right? So 991.2 will be our value for 2009 using the trend line progression. So let's jump over here and get that input. All right, so we've got all of our forecasting stuff done now. Now what we're going to do is we're going to go into our Unit 7, where we're using pivot tables to solve some problems, right? So we're going to jump over to the next worksheet. You'll see this one is for 16, 17, 18. We're going to use the worksheet called categories. So let me save my work. Done good stuff so far, so let's save it. Let's jump over here to 16, 17, 18 categories. And you'll see as you look at this, this tells you that for this data, looks like things have been sold. There are appliances of different types. There were dates for those transactions. There were quantities and revenues made, etc. Locations, state locations, as well as the markets that those transactions occurred in. So this is the data we're going to be analyzing with our pivot table. And what they want us to tell it in question 16 is determine the total sales revenue of fryers in the California market. Again, the important part of this, and if you remember from the reading assignment with the pivot table unit, was basically really get good at framing the question, understanding the question you're asking, and from there you can once you're good at that, you can then create your pivot table to reflect that question that you ask. You can basically query it well. So again, what we're looking for is the total sales revenue of fryers in the California market. That's going to help us place stuff into like the rows and the columns and the values appropriately, and then apply filters if needed. Okay, so let me jump over here to the spreadsheet. And what I'm about to show you is I'm sure it's not the only way to do this. Again, with pivot tables, there are lots of roads that can lead to Rome. I'm going to show you with the way my brain works. This is the way that I figured it out for myself. Might you figure it out differently? Sure. It's almost like programming. When you ask five programmers to solve a problem, you're going to get 5 different programs. And so pivot tables are sort of similar in that regard, and that's one of the cool things about them. But let's get started. So I'm going to make sure that my cursor, or I've got a cell highlighted somewhere in the data set. Go to Insert, create a pivot table. Say like, okay, I'd like to create this pivot table on a new sheet. Sounds good to me. Okay. So it creates a new sheet, and you'll see that it does that to the left of the one I was just working on. So that's the original data over here, and this is my new worksheet. You'll remember this from the pivot table unit. These are the different column headings right here, and you'll recall that the question wanted you to get the revenue for fryers in the California market. So I know revenue's in there, and I know that's the value I'm looking for, right? So I could just click on revenue, or I can drag and drop revenue into the values here, and it's going to make that guess for me. That's good. Next, what I need to do is figure out, okay, I'm specifically looking for fryers. Fryers fall into what the category column, and if you look over here at the data, you'll see in addition to fryers, other things sold are refrigerators and coolers, concession equipment, etc. And so over here in the pivot table, if I put category as my, let's say my rows, it's going to list those out. And so these are the different categories of stuff that's been sold. That's the revenue for each of those. So the only piece I'm missing at this point is the market, and the markets are the different. At this company, they broke stuff into like the Florida market, the Charlotte, North Carolina market. Sure, there are more in here, Kansas City market, etc. So they must be like the big focal points for where this company does business. And so what makes sense to me, okay, so I've got categories on row down here. So what if I take the market and I drop that into the columns part? Is that going to do it for me? Boom, there it is. And so as I look at this, let me just format this as currency, because that's what it is. Get this formatted as money. I'm going to do that as currency and take the decimal places away. As I look at this, the question was, what was the total sales revenue of fryers in the California market? Well, I can now find that out. So here are fryers in the California market right there. So there's my answer right there, 260,156. So 260,156, and do not include a dollar symbol, and don't include cents. And so let me get that number entered in there, and that was 260,156. And I could just type that as 260,156, or I could put 260,156. Your choice. Either way is going to work. That's my answer for that question. Okay, so I've got that answered in. So it just so happens that I can also answer question 17 with my current pivot table, the way it's already set up, using that same worksheet. Create a pivot table that tells me the total sales revenue of fryers in the Dallas market. So all I have to do, because the way it's already set up, just look for Dallas in here. There's the Dallas market right there. Fryers are down here, I believe, on there you go, Dallas. I was in the Dakotas, my mistake. So the Dallas market fryers is going to be 150,839. So 150,839. So let me get this entered for the next question. So there's my answer for 17. Now the next question is also going to come from the same worksheet, but it asks something different. It wants another bit of, it puts another bit of criteria in here. It says, okay, determine the total sale of fryers by sales representative. Specifically, they want to know how many, what's the dollar amount of fryers that Larry Vance sold. So what is the total sales of fryers by Larry Vance? So let me go back to my worksheet here. And what I'll do, I will take, at this point, I'm going to take the markets off of here, just drop it. And I've already got fryers right there. I could take the sales rep, just drop this down here in columns, and that tells me that, hey, there's your Larry Vance right there. I believe that's what I'm looking for, right? Larry Vance. So with that done, Larry Vance's fryer sales were 260,156. In 260,156, let me jump back over to the answers, and I'll put in 260,000 and 156. So that's Larry's sales. It's a lot of fryers. Good job, Larry. Our next set of questions, 19, 20, and 21. Let me save my work. And let me jump over here to questions 19, 20, and 21. And you'll see with this one, it's also some sales. It looks like sales data. Looks like there were internet sales. So there were in-person sales or on the phone sales as well as internet sales. There were different sales people, order dates, quantities, and then the sale amounts. So this is the data set for this next group of questions here. Okay, so these next three questions, they build on each other. The simplest question is this first one. Basically, what are the total sales for Jasper Witcher? So as I look at this worksheet here for questions 19 through 21, I'm going to create a pivot table. So I'm going to insert a pivot table on a new sheet. Okay. Makes my new sheet right there. And it's asking me what the total sales are for Jasper Witcher, who happens to be an account manager. So I need two things in this pivot table. I need total sales and I need the account manager. And so as I come back over here, my sales are right there. So I check my values, going to automatically put it in the values down here. And then if I just select account manager, just drag it down here to like rows, that tells me those are all of my account managers. Let me format this as currency real quickly. And remove the decimal places. So that tells me that Jasper Witcher right here sold 4,451,422. That's the answer for question number 19. Jasper's total sales was 4,451,422. So I'll get that entered and go to the next question. So as you can see, I've typed that into the answer for question 19. Question 20 adds a bit of criteria to it. It wants to know, of Jasper's sales, which of those were done through the internet? And so what I can do at my pivot table, it's going to be really easy. Over on my pivot table, go back to what's already there. You can see there's a column in here that talks about, was this an internet sale, yes or no, or true or false? So all I'm going to do with this column for internet order in the pivot table right there, I'm just going to take internet order, just add that as a column. It's going to break it out to those are the internet sales. Let me zoom in here just a touch so you can see that better. So you should be able to see that a little bit better now. So these are the internet sales. These are the non-internet sales right here. And for Jasper Witcher, those were his total sales. His internet sales were 2,388,219. So Jasper's doing a good job selling lots of stuff. So that's my answer for question number 20 right there, 2,388,219. All right, so there's my answer to question 20. Now, in this next one's cool. Number 21, it now wants us to isolate this to a specific year. It wants to know that question right there we just answered for the year 2024. And the way I'm going to go about this one is a little bit different than what you just saw a second ago. Now I'm going to use what's called a filter in my pivot table. So I'm going to jump over here to my pivot table, and just because I like to save a lot as we go, I'm going to save what we've done so far. And what I'm going to do is I'm going to take the internet orders here, and I'm going to move it to the filter area. Do you have to do it this way? No, you do not. This is the way that, again, in my brain, it just worked the best. So I'm going to take it and add it as a filter. Now what that means, you'll see I've gone back to my list of agents, as well as their total sales. Up here in the filter area, there's a drop-down box, and I can say, hey, do you want to see everybody? That's where it's at all, or do you want to see just the internet sales, or do you want to see just the face-to-face sales, or do you want to go back to where you see all the sales right there? So currently, it's showing all the sales for all the salespeople, and you can restrict that to internet sales or not right there. Now, next, what I want to do though is get the date. And in our question, we probably should have worded this question a little bit differently. We're talking about the order date. Which orders took place in 2024? So think back to when we did the dashboard project. And one of the charts that you made, it showed sales over months. A couple of different years. There were lots of months in those years. And the date data type in Excel is a complex or compound data type, and when you take it and add it to a pivot table like this, and again, we're working with the order date. That's what we're specifically working with here. So take your order date, and when you add that to, say, the columns or the rows, it's not just going to jump in there as order date. I'm going to left click, drag this down here and drop it. It adds it as order date, quarters, and years. And so you'll see there are plus signs and things up here. I can add and subtract things. All I want here is the years. So with quarters and the order dates, I can drag and drop these off to the side and just drop these out of the way. And that shows me for 2024 what Jasper Witcher's total sales were. Now what I need to do is restrict this to just the internet sales. So I come up here to the filter and give me just the internet sales for Jasper Witcher, which happened to be 837,120. So that's my answer to question 21, is what you see right there. Again, the way it was done, you take the order date and you drop it down here into, I put it on columns and then dragged off the things I didn't need, leaving only the years, and then filtering using the internet order up here as true or false, and leaving that at true for this specific one. So that's my answer for 21. Okay, so let's do our last set of questions here. So these last three, it's questions 22, 23, 24. And the pivot table you're asked to create is actually it's simpler than probably the other ones above it. What we want you to do here is we want you to work with the display. Once you've gotten a pivot table created, we want you to remember that you can adjust how the values that are showing up on the screen, how those display. You can see not only sums of things, but you can also see averages. You can see calculated amounts, and that's what we want you working with here. So the first question, 22, is we jump over here to the worksheet for this last one called Cookies and Crackers. It's a good way to end here. Please note, as you look at this, there are order dates over on the far left. There are regions in which these things were, are counted. For example, Boston, of course, is in Massachusetts, so that's over on the East Coast, whereas Los Angeles is over in California. That's on the West Coast. So there are regions as well as cities. There are categories of things, cookies and crackers, blah, blah, blah. There are products. There are like chocolate chip cookies. So you can just familiarize yourself with what you're seeing here. What I want you to notice is if you go from left to right in columns F, G, and H, this is a quantity of something. 33 of these were sold at $1.77, and the total sale of it, the price of that order, was $58.41. So this also could be called sale amount. It's called total price, but that's the product of that. That times that is going to give you that number that you see right there. So as we look at when you look at what we're asking you to answer for question 22, please create a pivot table to determine the total sales of chocolate chip cookies for Boston. So again, total sales, that's the value, right? Of what? Chocolate chip cookies. Where do chocolate chip cookies come from? As you look over here, as you investigate this closely, you'll see that the only thing that's chocolate chip is a cookie. So we can use this product column right here. So total sales of chocolate chips where? In the city of Boston. So that's how we're going to create this pivot table. So let's insert a pivot table on a new worksheet. Okay. And by the way, what I should have done is gone back here and named these sheets 1, 2, and 3. That's poor practice. I should get in here and actually give them names, useful names, answers for 22 through 24, answers for 19 to 21. Do you have time to do that during a final exam? Probably not, but as you're going in your working life, remember that. So let's go ahead and answer question 22. We want the total sale of chocolate chip cookies in Boston, right? So we know the total price is going to be our value. That's our sales amount right there. And remember that chocolate chip comes from the product column right here. So we can put product perhaps as our row. And we can look at the different cities in which we sold those things, right? So as we get back in here to our pivot table, we take the cities and maybe drop that as the columns. So that tells us, and we can then just take this and format this as currency. Again, go to your home tab. This is currency with no decimal places. So we can see that the chocolate chip total sales for Boston was 1,201. So that's our answer for question number 22. As you look at question number 22 right here. Again, the total sale of chocolate chip cookies for Boston. Let's get that entered. All right, so we've got that done. So now what we're going to do, we're going to use this pivot table we just made. We're just going to change how it's displaying stuff for questions 23 and 24. So what you just did there, you're going to keep using that same pivot table in here and here, but you're going to adjust how the values are being displayed on the screen. How are we going to do that? Well, with this next question, question 23, it says, okay, with that same stuff that you just calculated, determine the average total price for chocolate chip cookies for Boston. And so we've already got the chocolate chip cookies isolated in Boston. Now we just need to change it from the sum of sales to the average of sales. And how we do that, in the pivot table, we just, because this is the value field right here, select it, and we're going to click on field value field settings. We're just going to change it from sum to average. Okay, and we see that the average chocolate chip in Boston was 172. So that's our answer for question number 23. We've gone from the sum of the sales to the average of the sales, average sale being $172. So let me enter that in the answer here, $172. And my last question, it then wants me to take this one step further. And in this last question, we're going to create an appropriate pivot table to determine what percentage of grand total amount is chocolate chip cookies sold in Boston. So the way we do that, again, this what percentage of the grand total is chocolate chip cookies in Boston. Jumping back here to our pivot table. Currently, we've got this at average. We can see it says average of total price. We're going to change that back to the sum of total price. But what we're going to do is over here where it says show value as, we're going to come over here. We're going to do this as a percentage of the grand total right there and hit OK. And what that does for us, that shows us that that amount of chocolate chip cookies for Boston that we've already figured out makes up that percentage of the grand total. It's 3.6% of the grand total is chocolate chip cookies out of Boston. So that's what we're calculating. And again, we just got there through by clicking on the value down here, going to value field settings, and where to summarize, we switched it back to sum, show value as, and we put percent of grand total, and that's it. So 3.6 is our answer for the question 24. 3.6 is our answer there. get around to one decimal. And then lastly, of course, you have to agree with the honor statement right there, and then you hit save and submit, and you get your score. And so that should be 120 out of 120. And okay, I had to type my values back in there. I don't know if I timed it out or what I did wrong with it, but I retyped my answers, just type my answers back in, hit submit again, and there you go, 120 out of 120. So there you go. Hope that will be helpful. Again, go back to the homework from chapters 5, 6, or units 5, 6, and 7. That's where all of this came from. Talk with your teacher. You can help each other out as you study, but make sure, especially like with those forecasting techniques, make sure you're comfortable with those forecasting techniques, because once you get on the final, it's you and the computer. That's it. You're not going to be able to reach out and look at that stuff and remind yourself. You have to have that in your head as you're completing the final. So make sure you are prepared. I hope this is helpful. Thanks a lot, and have a good day.